Hello, everybody. There's a lot of you joining, so we're taking a couple of minutes here. This is an OpenShift Commons briefing. The topic this time is Kubernetes 1.12 or 1.12 update, and we're very happy to have Stephen Augustus, who's a Red Hatter, who is also the Kubernetes Product Management Chair, so well-versed in everything that's in this release, to give us an update. So without further ado, I'd like just to say that ask any questions in the chat. We're going to try and save them all for the end for Q&A, and I'll unmute you all afterwards because there's a lot to get through. And the recording of this will be put up on the YouTube channel and posted on Twitter and in our blog on OpenShift.com's blog afterwards. So you can find that and the slides there. So without any further ado, Stephen, take it away because we've got lots to talk about.
Hello, everyone. Thank you so much for joining us today for OpenShift Commons briefing. I am Stephen Augustus. I am so let's do that real quick. For Red Hat, I am a specialist solutions architect on the OpenShift Tiger team, which means I sell OpenShift. I do deep dives and architectural discussions around the OpenShift platform, as well as Kubernetes internals. From the Kubernetes side, I'm the PM Kubernetes Product Management Chair. I have also participated on the release team a few times. So for Kubernetes 1.11 and 1.12, I'm the features lead. So I basically am responsible for collating all of the features that will be active in the release, and kind of reaching out to different people to get a better understanding of what the implications are for customers and users based on those features. Lastly, I am the SIG Azure chair, so heavily invested in the Azure space, the integrations between Kubernetes and Azure, and the different API endpoints that we're working on. So features update. First and foremost, so TLS, or Transport Layer Security, that security we consider to be one of the cornerstones of Kubernetes. So it's very important that the story around being able to provide security and for nodes and the associated control plane components is well done, essentially. So we have this differentiation between day 0, day 1 operations and kind of day 2 operations. So one consideration for day 0, day 1 is, okay, well, I've bootstrapped a bunch of Kubernetes nodes. I need to handle certificate management in some way. I need to be able to provide the control plane, so the API server, the kubelet, the API server, the kubelet, the controller manager, the scheduler, and all the different integration points between those things, a means of providing an identity to each of those components, right? So the means for that was TLS Bootstrapping. So essentially, in a Kubernetes cluster, you can instantiate a cluster DA, or certificate authority, and that certificate or authority can delegate certificates out to the associated components for the cluster. So Kubernetes TLS bootstrapping was introduced in Kubernetes 1.4. So we've had a nice long journey to get to this point, but I'm happy to say that TLS bootstrapping is now GA as of 1.12. For those day 2 operations, often I have users and customers who spin up Kubernetes clusters, and as you may know, certificates have a specific time frame for validity, right? So what happens when certificates are no longer valid, right? You need some means of being able to rotate those certificates. In addition, you have to be able to react to security events, right? So the way you would react to a security event, a compromise of a certificate, would be to rotate it to. So that functionality, those day 2 operations from the TLS side, server certificate rotation for kubelets first have moved to beta in 1.12. Right. So what that means is we have the means to generate CSRs, or certificate signing requests, issue them to a cluster CA, and have those requests approved to issue new certificates for associated components. So that kind of delegates the responsibility of providing of having a cluster administrator handle this. So that's really that's really exciting to see that kind of evolution in the process. One, being able to spin up a cluster CA and delegate certificates, and then also have that cluster CA have the ability to listen to and approve certificate signing requests. So that's the TLS for 1.12. Moving on, Azure. So Azure I put up second because it's near and dear to my heart. The Azure VMSS, or virtual machine scale sets, moved to GA. So if anyone is familiar with common cloud providers, say AWS, and have spun up a cluster or set of nodes before and used something like Autoscaling groups, Azure VMSS is analogous to AWS Autoscaling groups, right? So we see that functionality. Move into GA for 1.12. With that move, we also so part of one of the holdbacks for introducing cluster autoscaler functionality to Kubernetes for Azure was around the support for VMSS, right? So now that VMSS is officially supported and it's in GA phase, we also see the integration with VMSS and the cluster autoscaler move into beta. So for people who are familiar with cluster autoscaler, if you're not familiar with cluster autoscaler, essentially what it does is it's an API endpoint that you can that is part of the cluster that can react to requests for new nodes, and based on the cloud provider that it's integrated with, can dynamically spin up those nodes, right? So in the case of AWS, it can react to AWS with the cloud provider integrations added, can react to requests for in cluster and spin up new nodes within that autoscaling group for workers, for masters, say. So now that same functionality is available on the Azure side. Finally, not on this slide, we're seeing improvements to Azure availability zones, excuse me. So again, availability zones analogous to availability zones within AWS. So these are basically, this is basically the ability to break out your compute nodes and your storage nodes and different things like that into separate fault and failure domains. So what that means is, if an Azure region goes offline for whatever reason, a region is now broken into a set of availability zones, right? So availability zones are classically a set of data centers rather. So now a region like a USD1 or US West 2, things like that in AWS, the similar concept is there, where multiple data centers are built within the region to provide support and tolerance for failures across racks, across the data centers, and across the region. Right? So that the ability to leverage availability zones will improve. One in 1.12, we see that as beta, and we'll continue to see improvements for that across 1.13. So scheduling. So I'm just as a heads up, each of these headings that I'm going through are aligned to SIGs, right? So SIGs are Kubernetes special interest groups. The Kubernetes special interest groups are essentially a way of it's a governance model that allows for delegation of activities that are specific to some subset of Kubernetes work, right? So, there's scheduling, there's Node, there are ones for cloud providers like Azure and AWS, there are ones for security, which is auth, there's ones for handling nodes, right? So things that happen on the kubelet level. So each of these special interest groups may have sub projects that get even more granular into the specific focus. Additionally, there are working groups. Working groups are cross-SIG efforts, and they're meant to be ephemeral, right? So things like multi-tenancy is one of the working groups, right? And that's work across node and scheduling and different things like that, right? So just be aware that each of these headings are specific to align with Kubernetes special interest groups, right? So quota by priority. Quota by priority is an extension of the pod priority and preemption feature. The idea with pod priority and preemption being, let's say that 5 times fast, right? The idea with pod priority and preemption is having the ability to assign a priority to the pods that you deploy, right? So being able to delegate priority to these pods means that I can now, if you consider something like the nice command in Linux Unix systems, right? So being able to say that, this process should do a certain amount of things and make sure and has a certain level of priority in the system compared to these other processes, right? So a user can specify, or a cluster operator can specify the priority that a pod has, right? Which and delegate to ensure that those resources get scheduled. So say you run a Kubernetes cron job or job and want to make sure, say that's batch processing for like your payroll system, right? And compared to that, you have a few pods that are doing load testing or some non-essential app, right? You want to make sure that payroll scheduling job is able to run and in the correct amount of resources without being affected by this load test for this non-critical app, right? So secondarily, there is the idea of preemption. So secondarily, there's the idea of preemption, right? So it's not necessarily always enough to define priority for a pod or set of pods. It's also important that those highly critical jobs that you're running, say this payroll processing imaginary service, is able to run regardless of the priorities that are happening on the cluster or on that node, right? So the idea of preemption allows you to essentially preempt non-essential workloads, right? So kick those workloads out, right? So that your crucial jobs can run, right? So the quota by priority functionality essentially allows you to define a set of quotas, right? So Kubernetes quotas are the the ability to set a scope of resources across, say, CPU or memory or namespace level, right? So now the quotas, now you can integrate quotas with the idea of priority, right? So there is I think it's resource quota by priority selector or something. I'm probably forgetting the API name, but anyhow, that feature moves to beta in 1.12. We also have the idea of tainting nodes by priority. So if you're aware of Kubernetes taints and tolerations, essentially taints say that you can essentially configure a set of labels that define a resource in a certain way, right? So in the instance of a node, the nodes, so say like the master nodes, right? So in a system like in certain configurations and distributions, we have the idea of configuring that node as a specific role and using that role to ensure that certain workloads don't get scheduled on those nodes, right? So your masters, you don't want to actually schedule application workloads on your masters, right? Because you want to ensure that the control plane can survive, right, and be able to schedule other work. So we do ensure that we set certain labels to ensure that that workloads won't be scheduled on things like masters, or in the case of OpenShift, like infra nodes, right? So then there's this idea of tolerations, right? So if you configure a deployment in a certain way, you can also configure the idea of a toleration, which means if a node matches this taint, I'm going to allow this workload to run, right? So it tolerates the taint. The taint basically says, don't run this stuff, but the toleration, if configured, will say it's okay to run this stuff here because I've specifically configured it that way, right? So now we're bringing this idea of we're basically layering on top of that API and allowing you to configure priorities for certain things, right? So I can configure the priority
Hello?
of. Hello?
Yes, we can.
All right. So that functionality moves into beta for 1.12. From the API machinery SIG, we have so API machinery is basically involved in lots of the little underlying bits that users and cluster operators may not concern themselves with day to day, but these are some of the most important integration points for the Kubernetes ecosystem. So if you're aware, Kubernetes is, a few people have talked about Kubernetes being like kind of like this kernel where there are a bunch of different programs that run around this kernel to kind of form this ecosystem that is Kubernetes, right? So you have the idea of the core Kubernetes code, and different things like the out of tree providers, the integration points that are built off of the client Go libraries, different things like so. All of the underlying mechanisms that kind of control the bits between those API integrations are mostly handled by the API machinery SIG, right? So the resource quota API moves to beta, and that is essentially being able to default certain quotas for, I say high cost resources here, but the idea is when you initially instantiate some resource on Kubernetes, you often have to come back and kind of think about, okay, well, what are the resources that that this pod or deployment will actually consume, right? How much memory, how much CPU should it be scoped to a namespace for certain teams, and different things like that, right? So by default, currently in previous versions at least, by default, when you run a pod, the scope is unbounded, right? So you can kind of do anything you want if you haven't set those limits, right? So this is so now we're starting to consider things like out of memory issues and CPU starvation and things of that sort, right? So the Resource Quota API brings in this ability to start defaulting the quotas for anything that's deployed across nodes that are handling some sort of workload, right? So you can start to begin to ensure that pods are scoped to a certain amount of resources, as opposed to every pod running unbounded, right? So you get a system that is going to be more considerate of the constraints of the actual underlying compute nodes, right? The API server dry run feature is really, really interesting. It's really exciting. If you've ever used some command line utility, you may be familiar with the idea of a dry run equals true, or apply equals false, or something like that, right? So the idea that you can test a set of functionality or a workflow without actually executing that across your nodes is pretty exciting, right? So we're bringing that functionality into the API server, and that's going to be starting off as alpha in Kubernetes 1.12. Really excited to see that feature, because that means a lot for the development workflow across the entire ecosystem, right? Being able to mock up what the flow of an apply against some sort of API is valuable, because one, you don't constrain the resources, you don't waste the time of figuring out what that action is actually going to do. And instead you have this dry run functionality where you can mock up and start stubbing code based on that, as opposed to waiting to kind of collate the results afterwards, right? So that we'll see lots of improvements and lots of things jump onto using that functionality in the future. Okay, so CLI. So SIG CLI is responsible for basically everything in the ecosystem around a tool you may be very familiar with, kube control. So server-side printing is the idea that when I request something from kube control and tangentially the API server, I want to make sure that information is being returned from the server itself and not something that's mocked from the client, right? So the ability to make sure that everything is essentially quote unquote pretty printed, right, and coming from the API server, or coming from whatever integration point from the API server, ensures that when we're building applications for or additional plugins and things like that for kube control, we can ensure that there is a consistent API that it's leveraging, right? We can trust the output that's coming from that command, right? So that functionality moves to GA in 1.12. So if you're familiar with the Git plugins, so the model for kube control similar here, and that's kind of where the inspiration came from, right? But if you've ever used kube control, you'll see that some commands have different effects, and some commands will have different outputs or different requests for flags, right? So we want to try to make that experience more consistent. And between these two features, kube control plugins and separating the repos for CLI utilities, both moving to beta, we'll start to see more of that stability and consistency across the kube control APIs. And so essentially, if you think about what's been happening across the last several release cycles around removing code from in-tree Kubernetes, from Kubernetes the repo, and moving it around so that we can iterate over the code a lot faster. The development cycle is faster. The feedback loop is faster, right? As opposed to working with this monolithic code base, right? So the same thing is happening on the kube control side. We're starting to pull out the different utilities used to generate CLI tools for kube control, and from an ecosystem level, so from the Red Hat side, we leverage the OC tool, which for OpenShift. The OC tool is essentially mocks up a lot of similar API interactions that kube control does as well, right? So the idea here is to allow anyone to write a tool if they need to that can leverage the same APIs and do it in a consistent manner, right? So the assumption moving forward is that when you're writing a kube control plugin, you make sure the plugin is named a certain thing and is in a certain location, is in your path, and the kube control will essentially aggregate the aggregate the path, the plugins that are in your paths and allow you to use it, right? So if you have a plugin that you decide to write that sets the context for a specific server, or it's a plugin that hones into a specific namespace so that you don't have to do a -n namespace for each of your commands, right? It will essentially locate the plugins that are well formed in your path, that are well named in your path, and basically aggregate them together and use that as this omnibus kube control, right? So that functionality is really exciting because again, it allows developers who are maybe not kube core developers to start to build these tools in the same way that the upstream team does. So network policy has been out for a little bit. Network policy is basically it's the ability to, it's essentially parts of an SDN firewall for the kube components, right, for a Kubernetes cluster. So the same way you would think of a firewall and routers, if you were building a traditional network, you would be setting routes, you would be specifying, your five tuple rules, right? So your port direction, the destination source IPs and protocols, right? So being able to do that within Kubernetes means we can start to carve out network space and start to create these means of isolation around multiple teams, around so whether it's teams, whether it's customers, however you decide to build your cluster, whatever use case that provides, we're starting to see this ability to create a firewall within essentially a firewall within Kubernetes, right? And prevent the ingress and egress of traffic from specific resources, right? So the egress functionality was introduced. Egress moves to GA as well as IP block in this release. What that means is, so egress is the ability to again have traffic leave the pod for a different destination. So before, when network policy was introduced, that was not possible, or that was not configurable via network policy at least. And additionally, the IP block functionality is, instead of having to hone in on a specific IP for these rules, you can now specify CIDR blocks as you would be used to doing in building a classic firewall, right? So both of those functionalities move to GA in 1.12. Right, so here is the node group. It's kind of very central to Kubernetes overall. So SIG node is responsible for a lot of the things that happen around the kubelet and how the kubelet interacts with the API server and the associated components. Right, so runtime class is introduced as alpha in 1.12, and runtime class begins to introduce this idea of having cluster scoping for container runtime properties. So I know that's maybe not super clear. What that means is I can now bubble up information about the container runtime that I'm leveraging for Kubernetes. So whether it be Docker or CRI-O or some CRI compliant spec, you're now able to leverage the properties of that within the Kubernetes layer, right? So what that means is I can start to, if I was to build for a simple use case, if I was to build an application that just simply gave me information about the node that was running, right? One of those pieces of information I'd want to know is the container runtime and the version of the container runtime, right? So, that starts to play into compatibility concerns, right? Around what version of Kubernetes am I running? What version of the runtime am I running? Are those two compatible? Is the version of the runtime that I have compatible with the operating system, right? And you know, this is a problem that we're attacking on the Red Hat side as well, right? So having an API to leverage around bubbling up that container runtime information to the cluster, because normally the cluster has no real knowledge of it outside of laying down the foundation and then installing having the containers run on top of that, right? So being able to bubble that information up is super important for starting to build integrations and guarantees around that. So the pod process namespace, another tongue twister, is moving to beta in 1.12, and pod process namespace sharing essentially is, as the name implies, allowing you to share information about PIDs within across pods that may be spanning namespaces. Right. From the kubelet device plugin registration side. So this is interesting because as I've been mentioning, the goal is to start to create less Kubernetes in tree code and more of this Kubernetes as a kernel and has surrounding components that work well and are known APIs, right? So we have things like CRI, which is the container runtime interface, DNI, which is the container network interface, CSI, which is a container storage interface, right? So when using these tools, you often don't have knowledge of exactly what spec you're using for that tool without doing some witchcraft, right? So the Kubernetes device plugin registration feature allows you we're starting to build this API where a device plugin, so CSI, say you're using something like OCS, like OpenShift container storage, right? CSI compliant, and you can basically you're registering CSI, you're registering OCS or some CSI compliant framework against the kubelet. So the kubelet has knowledge of what framework it's going to run, right? So this is also important from the network side. So knowing whether I'm using Flannel or Calico or Multis or some combination of multiple things, and being able to bubble that information out again to the Kubernetes control plane is important. So that functionality moves to beta in 1.12. So storage. We hear a lot about storage in the last few release cycles. Storage so I was mentioning, it's kind of a tie-in from the last slide. So I was mentioning CSI, and one of the things to really care about, and I think one of the most important things that we're starting to take heavy consideration into is the idea of topology aware dynamic provisioning, right? So topology aware is being able to know that when I build a Kubernetes cluster, say I build a Kubernetes cluster in Amazon that is cross availability zone, right? And remember that we said before that these availability zones can span multiple data centers, or the availability zones are usually codified as a data center, right? So now that I've built a cluster like that across multiple availability zones, if I decide to configure storage for my cluster, I need to ensure that the storage that I configure is close to the compute that I'm going to assign it to, right? So if I have storage that I've instantiated in US East 1A, right, and my compute node that I want to assign it to is in US East 1E, right? That's storage that's attempting to make a link with compute that is across a data center, right? So we're talking about high latency. We're talking about guarantee concerns, reliability concerns for your application, right? So we're starting to build. We're starting to have this idea of topology aware provisioning, where my compute and my cluster knows where my compute lives, my cluster knows where my storage lives, and if it's going to provision storage for my compute, it's going to make sure that that's the idea of being rack aware, being data center aware, being region aware, right? So I want to create storage that lives close to my compute nodes, right? So we're seeing all of the cloud providers actively work on this, and that functionality moves to beta. So it's happening in GCE, AWS, Azure, a few others that elude me at the moment. But this is an active effort on the CSI front for SIG storage to move this idea of topology aware provisioning forward. Right? So dynamic maximum volume count also moves to beta. So this is the idea that if I want to be able to essentially constrain the amount of volumes that I attach to a specific compute node, right? And so simple in itself, but that moves to beta for 1.12. And finally, something that I think everyone should be excited about, especially as you start to look at more and more stateful applications and how to kind of manage the ecosystem around a stateful application, is the ability to snapshot and restore volumes via CRD. So CRDs, if you're familiar with, if you've been around the Kubernetes ecosystem for a while, CRDs used to be TPRs, and TPRs are third-party resources. CRDs were introduced in, I think, 1.7, 1.8, and they're basically an ability to define a set of instructions for your Kubernetes cluster to do. Right, so this is essentially having a framework around being able to version these things to get status on them. So CRDs are the backbone of operators. So if you've heard of the operator framework and just the idea of operators in itself, it's the idea that we can encode human knowledge to Kubernetes native constructs. Right, so if I'm an operator who knows how to build Elasticsearch, and I want to make sure that I can run Elasticsearch within a Kubernetes cluster, right? There are some things that Kubernetes is not going to do for you, right? But you can write an application that says, I want to make sure I always ensure that I have this many master shards and this many data shards and things of that sort. You can encode that human operator knowledge to Kubernetes constructs, and that idea leverages CRDs to make that happen, right? So the idea that I can then do a kube control get Elasticsearch nodes or something like that, right? And be able to view those Elasticsearch nodes depending on your implementation, right? So the reason that this is important is now that we've moved past this idea of like Kubernetes is really good at stateless apps, right? Kubernetes is for the enterprise, we have to make sure that Kubernetes also works for stateful applications. And one of the parts of that story is being able to back up and restore the volumes that are attached to stateless applications. I don't want to destroy a pod that is attached to, that is leveraging some database and then have the database go away. Or in the event that happens, I need to know that I have some assurance that I can restore that database back to a known state, right? So this functionality for CRDs, the snapshot and restore functionality for CRDs starts off in alpha for 1.12, and we're definitely going to see some improvements across the next 2 or 3 release cycles. Right. So autoscaling. Autoscaling, again, if you're in a cloud provider. If you're in a cloud provider situation, we're also, we have the ability to do things like you leverage the cluster autoscaler, right? So cluster autoscaler hooks into the cloud provider APIs and can spin up nodes dynamically based on information from the cluster, right? In cluster, there are features that allow you to do that too. The primary one is HPA, or the horizontal pod autoscaler. So horizontal pod autoscaler essentially will can spin up new pods within some set, like a deployment replica set, what have you, and use metrics. Use metrics around your applications, or use predefined metrics that you set on when to scale across multiple pods, right? So now that the metrics server has been introduced and metrics server is more mature, we're introducing the functionality that functionality is graduating to beta in this release, to be able to define custom metrics within the metrics server and have the horizontal pod autoscaler leverage those metrics to define when and how it scales. Secondarily, there is so in this kind of rewriting of our improvement of the HPA, you see HPA v2 essentially. There's an improved scaling algorithm to make sure that there's not a lot of thrashing when your pods are scaling up or down, right? So if I have some event that requires me to scale pods, I want to make sure that happens quickly, and that there's also enough time and intuition from the system to scale them down in an efficient way, right? So if I react to some event for an event that happens for 15 minutes that causes a scaling operation, I want to make sure that event is actually done before I start to scale down these pods, right? Or we'll run into kind of this loop of, okay, I've started to scale down the pods, but this event is still happening. They need to scale them back up, or so there's a lot of thrashing between the scale up, scale down operations, and we'll see an improved algorithm for that scaling operation happen and move to beta in 1.12. Also from the autoscaling side, we have VPA, which is the vertical pod autoscaler, right? So as the names imply, right, horizontal versus vertical. So horizontal HPA is spreading across multiple nodes, and horizontal is spreading across multiple nodes, and the vertical is reconfiguring pods so that they have expanded limits, right? So so HPA is within the core code. VPA is an add-on to Kubernetes. So you would go to Kubernetes/Autoscaling or Autoscaler, excuse me, and that's the repo for it. And from there you can install. There's a script to add the vertical pod autoscaler functionality to your nodes. So we see that functionality move to beta in 1.12. Oh, title and body makes sense. So what's next, right? So we've talked about a lot of different features, and I noted on the OpenShift the CoreOS blog post that we're really seeking to be boring. Kubernetes should start to be more boring now that we've laid down and built the APIs for a lot of the baseline components for Kubernetes, right? So the next step and what we'll continue to see across 1.13, 1.14, and so on and so forth is we're really stability focused, right? So 1.13 is going to be a very, very tight timeline. 1.13 started, the development for 1.13 essentially started last week. But because of U.S. holidays, different events happening, so we've got Thanksgiving and Christmas coming up, and KubeCon in Shanghai and a KubeCon in Seattle. So and in betwixt all of this, the people who are actively working on these features are also going to be people who are attending these events and giving talks and spending time with their family on Thanksgiving and Christmas and the other December holidays. So the timeline is significantly shorter. Usually we spend about a quarter doing development and shipping, and now we're looking at a little less than it's going to be maybe a little less than 2.5 months, right? So this release we've gone back and forth about this idea of having stability releases versus feature focused releases, right? So So this is going to be another attempt at going for a stability release, right? So in that we want to essentially graduate the existing functionality of Kubernetes, right? Ensure that the code that is already there works, make incremental improvements, right? So one of the things that we're doing is we're officially deprecating support for etcd version 2, right? So everyone is or should be using etcd version 3, some variant of that, hopefully the latest at this point. So now that we've had this kind of deprecation notice up for a while, we're going to move forward with deprecating etcd2 for this release. Additionally, we want to see improvements to. I know there was a lot of fanfare about core DNS in the 1.12 release and the associated updates, and excuse me, the 1.11 release and those associated updates. And what we want to do here is make sure that so we ran into some scalability concerns around core DNS, and the scalability concerns did not present themselves towards the did not really present themselves until closer to the end of the 1.12 release cycle. And as a result of that, this was kind of the scalability team working out crushing different flakes and improving tests around running a high number of clusters. Like one of our really popular tests is our 5,000 node cluster test, right? So these tests will run for long periods of time, and it's because of that longer run time, it's harder to get signal faster, right? So as some of these stability concerns were kind of alleviated, we discovered some additional concerns around core DNS, right? So we'll hopefully see the starting of a move of core DNS as the default for all providers. Moving past the 1.13 cycle, right? So it's default for kubeadm right now, starting in 1.11. It was. We'll see it become default for OpenShift in future releases. So overall, we want to see core DNS, and now that we've kind of vetted out some of the scalability concerns around the project overall, focus is turning to make sure that this is default for the next few cycles, right? So again, we're really working on graduating existing functionality. Finally, I would be remiss if I don't do a plug for my sake. So we're going to be heavily product management focused for the next release cycle. We're trying to gather and kind of proliferate this idea of KEPs, which are the Kubernetes enhancement proposals, right? So this is basically how a SIG can present to the community the idea of new functionality, right? And then features, the features that we've talked about would be scoped within that KEP, right? So we're working out automation for that, a way to present that to the community so that you can, you as a passerby can go to some site and view all of the active KEPs for Kubernetes, see where the features are. We want to provide a system that is more robust and consumable to users, to SIGs, to contributors, to companies in general. So that's active work that myself, Jay Singer-DeMars, and Caleb Miles from Google are all working towards for the next release cycles. So stay tuned. Any questions?
Wow, that was a tour de force, Stephen. So thank you very much for that. There's a little bit of conversation going on in the chat, and but you mentioned the KEPs. Are the KEPs available to see now anywhere online, or is that a theoretical thing at this point?
Absolutely. So the KEPs are currently available. They're in the Kubernetes community repo. So allow me a few seconds to pull that up. But it would be github.com/Kubernetes/community, and then there's a KEPs folder, right? And then each of those keps are broken down by, so there are top level keps, which are basically wide-reaching Kubernetes events, right? So things like product management, things like things like TLS, things that are related to Node that touch basically every component of the ecosystem. And then there are SIG specific keps, right? So within each of those keps, you'll also be able to view a set of metadata that lets you know, one, who owns the kep, and then two, who are the participating SIGs within that kep. Right? So you get an idea of like the integration points around who's going to be actually attacking that work.
All right, and someone's put that. Josh has put that link in the chat, and you put in another one as well. So I'll add those in when I post this video, so people can find that. There was a little bit of chatter around the incorporation of this release's stuff into the Tectonic offering, and John Osborne gave a pretty good response. I'm wondering, John, if you want to unmute yourself and just reiterate that for the record.
Yeah, can you hear me, Diane?
Yes, I can. If you could just refresh that topic.
Yeah, sure. So right now, of course, CoreOS was an acquisition by Red Hat. So we've been working for quite a while with engineering to converge both what was the CoreOS Tectonic platform and the Red Hat OpenShift platform into one single converged platform. So that'll be a release of OpenShift that includes all the capabilities that were in Tectonic. And a lot of the other CoreOS technologies will live on as well. Like, for instance, Quay still lives on. CoreOS, the actual operating system, will be an embedded OS in the converged platform. The exact timeline for the release right now is TBD, but it will be the next release after 3.11. So when exactly that comes out, we're not 100% sure yet, but that'll be a converged platform that includes all the capabilities from Tectonic merged with OpenShift. There will be a beta program for people that want to adopt that. And I put my email in the chat in case someone's interested about joining the beta program. I can forward that to the appropriate folks at Red Hat.
We're almost at the top of the hour, so I want to respect people's time. There was one actual request as well for demos of some of these new features. And if you want to drop me an email at dmueller@redhat.com on specific topics that you're looking for people to talk about, I can track down speakers to do deeper dives on future briefings as well. I just spoke earlier that the 3.11 OpenShift release is going to be on 10/18, so in 2 weeks' time, rather than next week. So there's another opportunity with all the product managers giving their input. So we will probably do another Kubernetes interim stability release 1.13 or 1.3 at some point too when that comes out. So stay tuned for that. Go ahead, Stephen.
Yeah, so part of kind of the effort around doing the enhancement process and the features process and the marketing communication from a release team perspective is also to make sure that some of this information is available. While we're going to be so from the CNCF side, we'll also be doing a webinar on November 6th, which I'll be moderating as well. And that webinar will hopefully go through some of the. So what we're going to be doing is gathering some of the actual feature contributors and doing essentially like a 5 days of Kate's presentation, right? So there'll be a very, very deep dive into each of some of the highlighted features for 1.12.
Perfect.
We'll have I expect to see a Red Hatter or two. A lot of these features came out of our house, so I expect to see a Red Hatter or two on that presentation as well. But we're still working out some of the who exactly is going to be presenting. So stay tuned for that.
Yeah, if you send me the details for that, I'll make sure it goes out on the mailing list and up on along with the blog with this video too, so we can hook all that up and get the information out, so that
Sounds good.
I don't have to repeat it again. So that'll be great. So thank you very much, Stephen, for taking the time, and for everybody who joined us here. I apologize for a little bit of muting issues, but I think we managed to muddle through it. And we'll be back again next week with another update, and that one is on CoreOS itself. And so hopefully you'll all join us again for that. So thanks again, Stephen, and thank you to everybody else.
Take it easy, everyone.